Hi everyone, and welcome to our session on data visualization and communication. In this video, we're going to talk about how to effectively report data, create the right visualizations, and draw meaningful conclusions from what we see in a chart or graph. Let's begin with the question, why does reporting matter? Once we've done our analysis, our next big job is to share those findings in a way that others can understand. That's where data visualization and communication come in. The goal is simple. Make complex results easy to understand so others can quickly grasp the key insights and take action. There are two common ways to report data: tables and charts. Tables are best when people need exact numbers. They're great for comparing specific values or when precision is important. For instance, if you're showing quarterly revenue for 10 product lines, a table lets your audience look up exact numbers easily. Charts, on the other hand, are perfect when you want to highlight trends, relationships, or comparisons. For example, you can use a line chart to show a trend over time, like monthly web traffic, and you can use a scatter plot to show how two variables relate, like advertising spend and sales. Sometimes, to get the full picture, we need to break data down into subgroups, like by gender, age, region, or income. This is called data disaggregation. Why do we do this? First of all, to uncover hidden differences. A single average can hide major group-level differences. For example, a company might report a customer satisfaction score of 4.2 overall, but disaggregating by store could reveal one location scoring just 3.0, something you'd miss otherwise. Second, to ensure fairness and equity, especially in areas like healthcare or education, disaggregated data helps reveal disparities across groups. At last, to guide targeted decisions. It helps pinpoint where attention is needed. Instead of improving service everywhere, you focus on the underperforming group. But a quick note, only disaggregate when you have enough data in each subgroup. Too small samples might be unreliable or could risk privacy. Common techniques include faceted charts, which separate plots for each group, stratified analysis by splitting data into meaningful layers, using dummy variable for categorical data in models, and report the disaggregated summary statistics, like average income by department. A good example for data disaggregation is breaking total revenue down by product line, region, or customer type to spot which areas are over or underperforming. A good chart or graph helps tell a story fast. Data visualizations help us explore patterns, trends, and relationships and share those findings clearly. There are two key uses. In exploratory stage, visualizations are used during analysis to discover what's happening in the data. And in explanatory stage, visualizations are used at the end to communicate the results to others. To be effective, the visualizations need to show the right kind of chart for the question, match the structure of the data, and avoid misleading design choices. There are some key principles to follow to avoid misinterpretation. Use appropriate scales. For example, start axes at 0 when needed. Label axes clearly, say show units and variable names. Avoid clutter. For example, too many colors, 3D effects, or overlapping elements can distract audiences. Don't cherry pick, that is, show the whole time range or all categories. Use color meaningfully and appropriately. For example, to highlight trends or categories, not just decoration, and try to use colorblind friendly color scheme. And choose the right chart for the message that is every type of chart is good for a specific purpose. Let's talk about how we can use different types of charts to visualize data. There are many options out there, but we'll focus on some of the most common ones. We'll start with the column chart. A column chart is made up of vertical bars that represent the size or value of different categories. There's also a bar chart, which is very similar, except it uses horizontal bars instead. In both cases, each bar stands for a specific category, and the height or length of the bar shows how big that value is. So the taller or longer the bar, the higher the number it represents. One big advantage of using a column chart is that it's simple and easy to read. It's especially useful when you want to compare values side by side. Let's go through a quick example. Suppose we want to compare car sales last year between Toyota and Tesla. We could create a column chart with one bar for Toyota and another for Tesla. As you can see, the Toyota bar is clearly taller. We can quickly see that Toyota sold more cars than Tesla last year. It's a clean and visual way to get the message across. A scatter plot, also called a scatter chart. This is a powerful tool we use when we want to understand the relationship between two numeric variables. Each point or dot on a scatter plot represents one observation in your dataset. You put one variable on the x-axis, that's the horizontal axis, and the other on the y-axis, the vertical axis. Then you plot all the dots based on the values of those two variables. What makes scatter plots really useful is that they help you see patterns. You might notice that as one variable goes up, the other one tends to go up too, or maybe it goes down. You can also spot clusters, trends, or outliers, dots that don't fit the general pattern. Now, the main question we ask with a scatter plot is, are these two variables related? And if so, how? If the dots tend to move up and to the right, that means both variables are increasing together. We call that a positive linear relationship. If the dots move down and to the right, it means as one variable increases, the other decreases. That's a negative linear relationship. And if the dots are scattered randomly with no clear pattern, then the two variables likely have no linear relationship. Let's go through an example. Imagine we're looking at data from Costco and we want to see the relationship between advertising expense and sales revenue. We make a scatter plot where advertising expense is on the x-axis and sales revenue is on the y-axis. As we move from left to right, meaning advertising expense goes up, we also see the dots move from bottom to top, meaning sales revenue increases too. Since they're both increasing together, this shows a positive linear relationship. In other words, spending more on ads seems to be linked to higher sales. A pie chart is shaped like a circle, and that circle is divided into slices, kind of like cutting up a real pie. Each slice represents a category, and the size of the slice tells you how much that category contributes to the total. The whole pie always adds up to 100%, and the larger the slice, the greater the share that category holds. Pie charts are especially helpful when you're working with categorical data and want to compare proportions. In other words, when you care more about the composition than the exact numbers. Now, one tip to keep in mind, pie charts are best used when there are 5 or fewer categories. If you try to cram too many slices into one chart, it becomes hard to read and compare the sizes accurately. So keep it simple when using pie charts. Let's go through a quick example. Suppose we want to understand the sales breakdown across 5 product categories. We create a pie chart to visualize this. Right away, we can see that the JBI category takes up 48% of the total sales, which makes it the largest slice and the biggest contributor. On the other hand, JBT only makes up about 5%, so it has the smallest slice. From this one chart, we quickly get a sense of which categories drive the most sales and how the others compare. A line chart displays data points connected by straight lines. On the x-axis, that's the horizontal line. You usually place time, years, months, days, or even hours. On the y-axis, the vertical line, you place a numeric value like revenue, number of users, or temperature. Each point on the line chart represents the value of something at a specific time. And when you connect those points with lines, It helps you see how things change over time. You can spot whether the trend is going up, down, or staying the same. So in simple terms, a line chart tells the story of change, often with time running left to right. Let's take a look at an example. Suppose we're looking at Google's advertising revenue over 4 years. We plot the total revenue for each year and connect the dots. What we see is a clear upward trend. The line rises year after year. That tells us revenue has been growing consistently. Without even reading the numbers, we can already get the message just by following the shape of the line. Now, let's talk about the histogram, a very handy chart when you want to understand how your numeric data is distributed. A histogram looks like a bar chart, but it works a bit differently. Instead of showing categories, it shows how often values fall within certain ranges, which we call bins or intervals. Each bar in a histogram represents a range of values, for example, 0 to 2 days, 2 to 4 days, and so on. And the height of the bar tells you how many data points fall into that range. So the taller the bar, the more values it contains. In simple terms, a histogram helps answer the question, how is my data spread out? Histograms are great for spotting patterns, like whether your data is centered or spread out, peaks where most values are concentrated, gaps where no values appear, and outliers, values that are unusually high or low. One important tip, the way you choose your bin width matters. If you use too few bins, the histogram is oversimplified. You lose details. If you use too many bins, it becomes cluttered and hard to read. Also, remember that histograms are only for numeric data. If you're working with categories like product names or regions, you should use a bar chart instead. Imagine we're analyzing Wayfair's order processing times, specifically how many days it took to fulfill 20,000 orders. We create a histogram to look at the distribution of those times. From the histogram, we can see that most of the orders were processed in about 2 to 12 days, and the peak appears around 7 to 12 days. There are very few orders that took longer, which gives the distribution a right-skewed shape. That tells us the company processes most orders fairly quickly, but there are a few exceptions that take longer. Let's go over the box plot, also known as a box and whisker plot. This chart gives you a quick summary of how your data is spread out, where the middle is, and whether there are any outliers, which are values that stand out from the rest. A box plot shows you the minimum and maximum values, excluding outliers, the median, which is the middle value of the data set, the first quartile, Q1, and third quartile, Q3, which show where the middle 50% of your data lies. That's called the interquartile range, or IQR, and any outliers, which are values that are unusually high or low compared to the rest of the data. So in simple terms, a box plot helps you see the center, the spread, and any extreme values all in one chart. Let's go through a quick example. Suppose we're looking at the test scores of students in Group A. We create a box plot to visualize the data. From the plot, we can tell that the distribution is fairly symmetric. The median line sits near the center of the box, which is a good sign. The spread, or IQR, is about 13.3 points, which tells us there's moderate variability among the students' scores. And there are no extreme outliers, so the data looks clean and well behaved. Sankey diagram is a really useful visual tool when you want to show how things flow or move from one place to another. It uses arrows or paths to show the flow between different categories or steps in a process. The wider the arrow, the bigger the flow. So the width actually tells you how much of something is moving from one point to another. These arrows usually flow from left to right, and they can split, merge, or branch out depending on how things are connected. It's kind of like a map that shows movement rather than just totals. That makes it great for understanding how resources, people, money, or information are being allocated or distributed through a system. In this example, we're looking at what students do after graduating from 4 high schools. The Sankey diagram shows the paths they take, whether they go to college, enter employment, or take other routes. Here's what we see. High school A. Most students go to college, only a few take other paths. High school B. Students are evenly split between college, work, and other. High school C. A large number of students choose alternative options, with fewer heading to college or employment. High school D. Most students go into the other category and very few go to college. So what can we conclude? College is the most common path overall, especially for students from schools A and B, but schools C and D have a larger share of students choosing non-college or alternative paths. Stacked bar charts are just like regular bar charts, but instead of showing just one value per category, each bar is divided into sections to show multiple subcategories all stacked on top of each other. They're great when you want to show both the total value and how that total breaks down into parts, all in a single bar. They also save space compared to separate bar charts for each category. Now let's look at 2 types. On the left, we have a regular stacked bar chart showing the number of beers sold broken down by type. For example, stout, ale, IPA. Each section of the bar represents one beer type, and the height of the whole bar shows total beer sales for each product. On the right, we have a 100% stacked bar chart. This one shows the same breakdown, but instead of using counts, it uses percentages. So each bar is the same height, and you're comparing proportions instead of totals. Now, a quick note. It can sometimes be tricky to compare individual values across stacked bars, especially for the middle or top sections. But these charts work really well when your goal is to show how parts make up the whole, or track changes in composition over time. Let's say you're comparing beer sales in 2025 and 2026. You can create a stacked bar for each year, and within each bar you break it down by type of beer sold. This way, you can easily see not only how total sales changed, but also how the mix of beer types shifted. Maybe people started buying more stout and less IPA. Alright, let's wrap up the lecture by talking about how to choose the right type of chart based on the kind of data you're working with. If you're working with categorical data, like product types, regions, or customer segments, you'll want to go with charts that are great at showing categories and proportions. That includes pie charts, to show how each category contributes to a whole, bar charts for comparing categories side by side, stacked bar charts to show how different groups add up within each category, and Sankey diagrams if you want to show how things flow or move between categories. Now, if your data is numerical, meaning it's made up of numbers like prices, scores, or quantities, then consider charts that show distribution, trends, or relationships. These include histograms for showing how your numbers are spread across ranges, box plots to summarize the center, spread, and outliers, line charts, especially when you're tracking changes over time, and scatter plots to explore the relationship between 2 numeric variables. Choosing the right chart makes your message clearer and your insights easier to understand.